Hello friends, this is Kishore Kumar. Today we are going to learn about the data types in Python 3. This tutorial is for beginners only. In this tutorial we are going to learn about standard data types in Python 3, which is also called built-in types in Python 3. In standard data types we are going to learn about Boolean data types, numeric types, sequences, sets and mappings. And next, finally, we will going to learn about mutable versus immutable objects. In standard data types, every value in Python has a data type. Every value in Python has a data type since everything is an object in Python programming. The data types are actually classes and the variables are instance or object of these classes. For example, here 25 is a numeric data type. It is a class, and the variable where one is the variable. This is the object of the classes. The data stored in memory can be of many types. For example, a person's age is stored as a numeric value and his address is stored as alphanumeric characters. As in the official Python documentation, the built-in data types are Boolean types, numeric types, sequences, sets and mappings, and few more not discussed here. These standard data types are used to define the operations possible on them and the storage method for each of them. Data types determine whether an object can do something or whether it just would not make sense. In other programming languages often determine whether an operation makes sense for an object by making sure the object can never be stored somewhere where the operation will be performed on the object. This type system is called static typing. Python does not do that. Instead, it stores the type of an object with the object and checks when the operation is performed whether the operation makes sense for that object. This is called dynamic typing. So Python is a dynamically typed program. The standard data types are Boolean types, numeric types, sequences, sets and mappings. In Boolean types, the values are true and false only. True is equivalent to integer 1 and false is equivalent to the integer 0. In numeric types, there are three types of numerical types in Python. First one is the integer, float and complex. In sequences, strings, list, tuple, bytes, byte array. In sets, set and frozen set. In mappings, dictionary. We are going to learn about these data types in this tutorial now. First one is the Boolean types. The built-in Boolean types are true and false. These are the two values only. It is actually the Boolean types are useful in conditional expressions like if, else, just like that. And anywhere else you want to represent the truth or falsity of some condition. It checks the condition conditions truth and falsity. The it is equivalent to these true and false are equivalent to the integers 1 and 0 respectively. In fact, conditional expressions will accept values of any type, treating special ones like Boolean false, integer 0 on the empty string as equivalent to false only, and all other values are equivalent to true. But for safety's sake, it is best to use only Boolean values in these places. The bool, this is the Boolean method. It converts a value to the Boolean values, true or false, using the standard truth testing procedure. The syntax for this method is bool bracket of value. Here, it is not mandatory to pass a value to bool method. If you do not pass the value to the Boolean method, the Boolean method returns false value, FALS, false. In general use, Boolean method takes a single parameter only value. The Boolean method returns false if the value is empty or false. If you do not give any value or the value is omitted, then the Boolean method returns false. If the value is true, then it returns the true value. The following values are considered false in Python. See here, first one is the none, second one is the false, 0 of any numeric type, integer 0, floating point 0.0, complex 0j, empty sequences, parentheses, square bracket, empty string, empty mappings like this, curly braces, objects of classes which has double underscore bool under bool double underscore parentheses or double underscore length parentheses double underscore. These two methods, if these two methods returns 0, it gives the false value. All other values except these values are considered true. If these values are if these values are given, the Boolean method gives false only, and remaining values if you given, it gives the value true. Now let's see one example here. An example here. See, for example, let's say variable test. It is a empty list. There, here you did not given any value to the variable test. Let's see the print of test comma is a string here, boolean, this is the syntax, test is the here value given. It gives the output, the empty list is a false, as I have just the empty sequence here is the empty list, it returns the value false. Okay, next we will give one value, print it gives 0 is true. Here you have given the value 0, it gives the true. It is not a empty list. In the earlier case you have given empty list, it gives false. If you given with a value, it gives true. Let's see one example here. Test is equal to 0, print test is boolean of test. Here 0 is false given. See here, the 0 of any numeric type. Here 0 is the numeric type. Here, if you given 0 to the variable, the boolean value of this variable gives false. Okay. Next, we will test the floating point value 0.0. Print test is boolean of test. It gives the false. Here we have given the value with the floating point 0.0. It gives the false value. Okay, it returns false. Okay. Next, we will give this none value. It must give the output false. See here, none is returned with the value false. So none, false, 0 and everything, whatever you given at the input, it returns the false output. Now test the true condition. If you have given true value to the tester, check the value of true. Bool test. It gives true. You have given the value with the true, then it gives true. If you give false, it gives false. False is false. Here false, it gives the returns false. If you have given true, it gives true value. True is not in this list. So keep it in. So we have to remember all this. Now if you give one string, that's equal to easy string, print test is boolean of test, then it gives easy string is true. But if you given with the empty string, print test is boolean of test, the empty string is false. Here the empty sequences and the empty strings are given with false value. Next topic is the numeric types. Python supports 3 different numerical types. They are integer, float, and complex. All integers in Python 3 are represented as long integers. Hence, there is no separate number type as long. Actually, the number type long is available in Python 2.x, but in Python 3.x, there is no separate number type long. Please remember it. Here, these are all the examples for the numerical types. This is the integer type 10, 200, minus 6.7, minus 657. All these are all the just some example to present the integers. Similarly, float 0.0, 35.40, minus 45.7, and similarly complex numbers also. Actually, to present an octal number, after this is a 0, after you have to use the O. If you want to represent an hexadecimal, after that, after 0, you have to use the X. This is the hexadecimal. In complex numbers, X plus Yj. Number data types store numeric values. Number objects are created when you assign a value to them. For example, if you assign a value 1 to the variable 1, here 1 is the numerical type integer. This is assigned to the variable 1. Then when the value is assigned to the variable, number objects are created. Okay. Now we will see how to know the variables class and values class. To know that variables class, you have to use the function type, type parenthesis. And there is one more question: how to check an object's class? To check the object's class, use the isInstance function. Using these two functions, let us see one example here. For example, let us take value a equal to 5. Let's see the number 5's type using the print function. A is of type of A. It gives the type of integer 5 is the integer. All the number data types are belongs to the classes. Similarly, let us take one more example. Now we have taken integer. We shall see the floats type 2.0. Print A is of type of A. Here we will get the number type floating point 2.0 is the float. Float is also a class. Similarly, we will see an example in complex notation. Print A is of type type of A. See here, 1 plus 2j is of type class complex. Okay. Integers can be of any length. You can type the integers of any length. Actually, it is limited by the memory available. We will see. An example here: 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now we'll print the value of A. See here, whatever we have given value to the variable A, that is given as the output. So here it limits by the memory only. You can take any of length in integers. Now let us see the floating point. For example, b equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now see the value of b. See here, it gives only, after decimal point, only 18 decimal places. Remaining are truncated here. So it is depending on the version you are using. Similarly, we will take one more example in complex. C equal to 1 plus 2j. Print C. See here, the value is 1 plus 2j. Complex numbers are written in the form of x plus yj, where x is the real part and y is the imaginary part. Here 1 is the real part, 2j is the imaginary part. Now we will see Python number conversions. How? See here, this is the integer of x. Here x is a value. It is converted into the integer. Similarly, x here float of x gives x value is converted into float. Similarly, x value into complex, and x comma and y value is converted into complex. Let's see one example here. For example, we will take integer of x. For example, x value equal to 25.457. Print. Now we will convert this x value into the integer value. See, it gives the integer value. Here x value we have assigned a floating point number, but it converts to the integer value. The decimal places are truncated here. Similarly, we will see a float example. X equal to 25. It converts this x value to be converted into float. Here x value we have given 25. We have converted 25 value into the float 25.0. It is the float output. Similarly, we will take for complex value x equal to 20. Complex x. See here, we have given the x value is a integer. Here it converts into complex 20 plus 0j. It is a complex number. For example, if you given x equal to 5 and y equal to 6. Let us see it in the converted into complex of x comma y. See here, we have given x value 5 and y value 6. It is converted into the complex 5 plus 6j. Okay. Sequences. In sequences, we are going to learn about the strings, list, tuple, bytes, and byte array. These are all the sequences data type. First one is the strings. Strings String is a sequence of Unicode characters in the range of U plus 00000 to U plus 10FFF. Strings in Python are identified as a contiguous set of characters. These are represented in quotation marks only. Python allows a single or double quotes. Strings can be taken using the slicing operators. The subsets of strings can be taken using these two slicing operators with the indexes starting from 0 to the beginning, and if you want to take from the in reverse order, it starts from the -1 from the end. Here the plus sign is the string concatenation operator and star is the repetition operator. All we will see in an example using all these types. A multi-line strings can be denoted using the triple quotes like this or like this. Use here. See one example here. See here one example. S is a string. S equal to S is a variable here. This is a string using this single quotations. Okay, this is a valid syntax, and you can use double quotations for a string. This is also a valid syntax for the string. And if you want to write the multiple strings like this, use at the beginning you have to use 3 single quotations or double quotations, whatever you type. It will take the Python interpreter. Multi-line string can be written in second line with the help of triple quotes. After completing the string typing, use these 3 single quotations. It is to be used at the beginning and end also. It is also a valid syntax. Actually, strings are immutable. The slicing operator can be used with the string also. Let us take one example. In that example, we will show how to use the slicing operators, concatenation, string concatenation operator, and repetition operator. For that, take one string, just like a string is str is a variable HELLO, hello, WORLD. Okay, here we have taken the string hello world. Now see the string. This is the print function string. See here the print function for the variable string. See hello world. Similarly, now use the slicing operator. Print string zero. Here I am calling the string of H. Here 0 is the index of the string first letter. It starts from the 0. Index starts from the 0. H is the 0, E is the 1, L is the 2, 3, 4, space is the 5, 6, 7, 8, 9, 10 and 11. So here we are asked for 0 of the index. It returns the value H. Similarly, if you want to type, if you want to slice from 2 to 5, here number 2, here the 2 index starts from here. First one is 0, 1, 2, L, L, O, 2, 3, 4. Here it comes 4. Last one 5. Here the Python interpreter returns 2 to 4 characters only. The last one here the last one is the index 5, but it gives only up to 4 only. Okay. Similarly, if you want to type from second character to until the end, just type like this, 2. Here from 2 onwards until the end of the string, it gives the output like this, 2 colon. Similarly, if you want to repeat the string using this asterisk, print string see here the string with multiplied with 2, then 2 times it prints hello world. Okay. If you want to concatenate the string like this, type like this, print string plus test. See here hello world test. It gives the output like this. Actually, strings are immutable in Python. If you want to see let's see the immutable type of the string. Just update the 5th character with small d, like this. Here fifth one is the HELL 0 1 2 3 4 5 space. Then it gives the error because it is a typing error. String object does not support item assignment. So hence it is called the immutable type. In sequences, the next standard data type is the list. Lists are the most versatile of Python's compound data types. It is an ordered sequence of items. In list, all the items are separated by commas and enclosed with the brackets. Lists are similar to arrays in C. One major difference between them is that all the items belonging to a list can be of different data types. You can use different data types in a list of the Python. The values stored in the list can be accessed using the slicing operators with indexes starting from 0 from left to right. If you want to access from right to left, the index starts with -1. Here also, like strings, you can uh, you can add concatenation operator and you can use repetition operator. Let's see with an example here. Let's take one variable list, name list. List in list, you have to use this square brackets for the list. Here I'm using a string ABCD, comma 786, comma 2.23, comma Kishore, comma let's say 70.2. This is a list with different data types. All the elements are different. Here ABCD is string and 706 is a integer, 2.23 is a floating point, again string and again floating point. Just like that. Now we will see print of list. See the elements of the variable list. See here, these are the ordered data types. Okay, now we will access first element in the list. It is the ABCD. Okay, using the slicing operator, list 0. Here you are going to access the first element of the list is the ABCD here. Similarly, next one also list of 1, 7, like this. If you want to access from item number second one to 3, print list of 1 is to 3. Okay, here index number 1 is the 786, 2 is the 2.23, but the 3 index number 3 it will not give, only up to that is the limit of the maximum maximum number. maximum index actually. Similarly, if you want to access from second index to the end of the list, like sequence, here you have accessed from second 0, 1, 2, 2.23, Kishore and 7.2 to until the end of the list. Okay. Now take one more list. Try tiny list equal to 1, 2, 3, comma Kishore. Now use the repetitive operator for this tiny list variable. See here, 1, 2, 3 Kishore is the tiny list elements. These are 2 times multiplied with these are 2 times printed here by using this repetitive operator. Similarly, if you want to concatenate this tiny list with this list, just like type like this, list plus tiny list. See here, the list elements ABCD 706, all these are up to here, and this is the tiny list. Lists are mutable. The mutable meaning is value of elements of a list can be altered like this. Let us take one example here. A equal to 1, 2, 3. This is a list. If you want to update this last element with the 4, you have to use this syntax a of 2 equal to with 4. Then print a. Here 1, 2, 3 will be replaced with 4 like this. In the sequence data type, next one is the tuples. Tuple is another sequence data type that is similar to the list. The only difference between the tuples and the lists are the tuples are the immutable, but the lists are mutable. Tuples once created cannot be modified. Tuples are used to write protect data, and it is usually faster than the list. It cannot change dynamically. A tuple consists of a number of values separated by commas. All the values are separated in a tuple with the commas. Commas are separating the values. And all these values are enclosed within the parentheses. The main difference between lists and tuples are lists are enclosed in the square brackets and tuples are enclosed in the parentheses. Once the values are entered in the tuple, it cannot be updated. Tuples can be thought of as a read-only list. Let's see one example here. Open the ideal. First one is the take one variable tuple. This is a tuple. Now enter the values in the tuple. Let us take one string, and the second one is an integer, and next one is the float. Next again a string. Next a floating point. This is the all the values are entered in the tuple. Now we will access the all the values of the tuple like this. See here, all these values are different data types but enclosed in the parenthesis. This is the tuple. Now we will access first element of the tuple. Print tuple like this. Same like list, you will access. You can access same like list. Here 0 is the first element here. Similarly, take one more example, tuple of accessing 1 to 2 second. See here, first one now index number 1 is 786 2.23. Okay. Similarly, if you want to access from second index, zero, 1, 2, 2.23 the second index, Kishore and 7.2 up to the end of the tuple. Let's take one more tuple, tiny tuple, equal to 1, 2, 3, comma. Okay. Now we will repeat the values of this tiny tuple. Print of tiny tuple star 2. See here, the two elements are here repeated 2 times. Similarly, concatenate of these two tuple values. Print tuple tuple tiny tuple. These two values are concatenated. Tiny tuples, two values are concatenated in the tuple. Okay. If you want to attempt to update a tuple's value, it gives an error like this. Tuple 2 with 1000. Second index 0, 1, 2, 2.23 is updated with 1000. It gives the error. So tuples are the immutable, but list can be updated. Just take one example here. List equal to, let's take one example here. List ABCD 786 2.23 is a string and a floating point. Here we can update the elements of the list. For example, update at the second index of the list with the 1000. 2.23 is replaced with or updated with 1000 value. See the list values. See here, the second one is updated with 1000. The next topic is the bytes. The bytes method returns a immutable bytes object initialized with the given size and data. Actually, this bytes method only available in Python 3.x. The bytes method returns a bytes object which is an immutable. What is the meaning of immutable? It cannot be modified. It is an immutable sequence of integers in the range of 0 to 256. Now we will see the syntax of this method. Bytes bracket source comma encoding comma errors. These three parameters here we can use with this bytes method. The first parameter source, actually source, this is a optional. This source is used to initialize the array of bytes. Next, encoding. It is also a optional parameter. If source is a string, then use the encoding of the string. The string encode method returns encoded version of the given string. Since Python 3.0, strings are stored as Unicode. That is, each character in the string is represented by a code point. So, each string is just a sequence of Unicode points. For efficient storage of these strings, the sequence of code points are converted into set of bytes. This process is known as encoding. So this bytes method used for that purpose, encoding purpose. There are various encodings are there, but the popular encodings are UTF-8, ASCII, etc. etc. The next parameter, errors. If source is a string, the action to take when the encoding conversion fails. It is also an optional parameter. The bytes method returns a bytes object of the given size and initialization values. Let's see one example here. Here in that example, we will convert a string into bytes. Let us take one variable string Python is interesting. Now we will convert this string Python is interesting into the bytes. For example, array. Here array bytes. This is the syntax of string, comma. We will convert into UTF-8 encoding. This is the encoder. This is the popular encoder. Here we are using the bytes method for this string. It is to be converted into the byte code, that is UTF-8 encoding. Now see the print error. variable. See here the beginning of the here B is the it represents the byte code. Python is interesting. This string is converted into the byte code UTF-8 format. Similarly, create a byte of given integer size. Here, one variable size equal to 5. Let us take one 5. Array equal to bytes of size, variable size. Now print the variable array. See here. Here one byte is created in the given integer size 5. Here this is the byte code in the given size of integer. Now let us take one more example. Here we will convert iterable list to bytes. Let us take a list equal to 1, 2, 3, 4, 5. Let us take one more variable array bytes of list. Now see the values of array. See here the list values are converted into the bytes UTF format by default. 0, 1. This is hexadecimal. X means hexadecimal notation. It converted into the bytes code. Okay. In the sequences data type, the next method is the byte array. The byte array method is just like bytes method, but byte array is mutable. The bytes method is immutable. The byte array is only available in Python 3.x. The byte array method returns a byte array object which is an array of the given bytes. The syntax of the byte array method is the byte array of source, encoding, errors. The byte array method returns a byte array object which is mutable sequence of integers in the range of 0 to 256. The byte array parameters are, first one parameter is the source. Source is used to initialize the array of bytes. Next, encoding format. If any errors are there, use this as a, these three are the optionals. The byte array method returns an array of bytes of the given size and initialization values. Now let's see with the help of examples what is the bytes array method do. First example, array of bytes from a string. Let us take one string. Here Python is interesting. Now see one array. Let us take one array equal to byte array of string is an variable here, and encoding format is the UTF 8. Now print the array value. See here, byte array of B is the byte code. Python is interesting. Here we have converted the string Python is interesting into the array of bytes. This is the output. Now we will see next example. Array of bytes of a given integer size. Let us give the size as the 5. 5 is an integer, and array equal to byte array of size. Now print the value of array. See here, this is the given integer. The array of bytes is given in the integer size. Integer size here given 5. So in the 5 hexadecimal notation. Now let us take one more example. In this for array of bytes from an iterable list. For example, take an list equal to 1, 2, 3, 4, 5. Now array equal to byte array of list variable. Now print array. See here, all these list elements are converted into the byte array like this. In the sets data type, there are two sub data types. One is set and next one is the frozen set. In the set, a set is an unordered collection of items. Every element is unique, no duplicates, and set is a immutable, which cannot be changed. Set available as a standard data type since Python 2.6. The set itself is mutable. The set itself is mutable. We can add or remove items from it. Sets can be used to perform mathematical set operations like union, intersection, symmetric difference, etc. etc. How to create a set? A set is created by placing all the elements or items inside curly braces like this, separated by comma or by using the built-in function set. It can have any number of items and they may be of different data types: integer, float, tuple, string, etc. etc. But a set cannot have a mutable elements like a list, set, or dictionary as its element. Let's see one example here. For example, a equal to 1, 2, 3. Now print a. Here the a is given the elements with 1, 2, 3. This is a set. Similarly, we can give different data types for the set elements. Let us take one a equal to for example 1.0 is a floating, hello is a string, and tuple 1, 2, 3. Print Let us see the set values of A. See here, 1.0 is a floating, it's a tuple, it's a string. Now see one more example here. Set do not have a duplicate values, like A equal to 1 comma 2 comma 3 comma 4 comma 3 comma 2. Print A. See here, we have given the variable A with duplicate values 1 2 3 4 3 2. Here 3 and 2 are the duplicate values. When we call the two variables set values, it gives the unique values only, like this. Now see one more example. Set cannot have mutable items, like this. For example, A equal to 1 comma 2 comma 3 comma 4. Here 1 2 are the numerical types, integer types, but 3 comma 4 given the list elements. But in set you cannot give this list elements. If you give that, the interpreter gives type error, unhashable type list. See here, these 3 and 4 are the list items, so it cannot accept. Now let's see one example. From a list we can make a set. From the values of list we can make a set values, like this. For example, A equal to set of this is the list values 1 comma 2 comma 3 comma 2. Here 1 2 3 2, these are the list elements. From these list elements we can obtain the set values, like this. Print of A 1 2 3. Here duplicates are also removed, so we have created a set values from the list values. Creating an empty set is a bit tricky. Empty curly braces will make an empty dictionary in Python. To make a set without any elements, we use the set function without any arguments. To make a set without any elements, we use the set function, like this. Using this function we have seen just now. Using this function we make the set from the list. List is a mutable type. From that elements we made some set values. Let us see one example here. We will initialize the A with set values. For example, A equal to this. This representation is the initializing the dictionary values. Now see the type of this empty set value. What is that? Print type of A. See here, the values of A is the dictionary, so it is the empty dictionary. We can create like this. If you want to create a empty set, just like this, you can like the you can get the empty set values using this set function a equal to set. Now you can see that set you can see the class type of a by using print function. It gives the set the a's class method is the set here. Set is defined by values separated by comma inside braces. Items in a set are not ordered. Let's see one example. A equal to 5, 2, 3, 1, 4. Now see the value of A. See here, we have given in unordered set values, but output also in the different order. So you can deduce from this. Now see the type of the print of type of A. It gives the A is the set class. Okay. Now we will see one more example here. We can perform set operations like union, intersection on two sets. Sets have unique values. They eliminate duplicates. For example, if you give duplicate values to the set elements like this, print of A, it gives only the unique values. Since set are unordered collection, indexing has no meaning. Here you cannot slicing, you cannot use a slicing operator. It does not work. Let's see one example. A equal to 1, 2, 3. For example, we can slice, we can call the element with indexing. Index number 1. What it gives? The type error. Set object does not support indexing. So in the sets data type, there is frozen set data type. It is frozen set is just like set data type, but the frozen set is immutable. It is available since Python 2.6. Frozen set is a new class that has the characteristics of a set, but its elements cannot be changed once assigned. While tuples are immutable lists, frozen sets are immutable sets. Sets being mutable or unhashable, so they can't be used as dictionary keys. But frozen sets are hashable and can be used as keys to a dictionary. Frozen sets can be created using the function frozen set. Like we will see one example, just like this. Play equal to FRO ZGN SET frozen set of list 1, 2, 3, 4, just like this. Now take one more variable b equal to frozen set of 3, 4, 5, 6, just like this. The frozen set method returns an immutable frozen set object initialized with the elements from the given iterable. Frozen set is just an immutable version of Python set object, while elements of a set can be modified at any time. Elements of frozen set remains the same after creation. Due to this, frozen sets can be used as key in dictionary or as element of another set. But like sets, it is not ordered. The elements can be set at any index. Let's see the syntax of frozen set method. Frozen set of iterable. Here, iterable is the optional parameter. The iterable which contains elements to initialize the frozen set. Iterable can be set, dictionary, tuple, etc. The frozen set method returns an immutable frozen set initialized with elements from the given iterable. If no parameters are passed to the frozen set method, it returns an empty frozen set. Let's see one example how frozen set works in Python. Let's take a tuple of vowels. Vowels equal to A, E, I, O, U. Now we will change it to F, frozen set equal to frozen set of vowels. Here we converted into frozen set the vowels values. Print F set. See here, all the elements of vowels are the here tuple of values are converted into the frozen set. The frozen set also unordered list of items. Now we will see the empty frozen set just like this. Print FROZENSCT frozen set of empty. This is the empty frozen set values. Now we will see frozen set method for dictionary values. When you use dictionary as an iterable for a frozen set, it only takes key of the dictionary to create the set. Like this. Person is a variable here. Let's take key value name value is the Kishore and key is the age and value is the 23 and value is the male. Now F set is equal to frozen set of person. Here all these will key value pairs are converted into the frozen set. Let's see the output. F set frozen set of sex, age and key and sex, age and name. Here it takes only key values only, the keys only. It does not take the values. It only take the keys. The Trojan set operations, like normal sets, Trojan set can also perform different operations like union, intersection, etc. etc. The Python's dictionaries are kind of hash table type, also called hash maps or associative arrays, which means that an array element of the list is associated with a definition, rather like a map in Java. They work like associative arrays or hashes found in Perl and consists of key value pairs. A dictionary key can be almost any Python type, but are usually numbers or strings. Values, on the other hand, can be any arbitrary Python object. In Python, dictionaries are defined within braces, in these curly braces, with each item being a pair in the form key colon value. Key and value can be of any type and accessed using the square braces. Let's see one example here. Let's take D equal to curly braces. 1 is a key and value is the value, and key is the key colon 2 is the value. Let us see the type of this variable D. It is the dictionary class. We use the key to retrieve respective value, but not the other way around. Let's, for example, take one example here. Dict is a variable. It is a empty dictionary. Now, dict of ONE1 equal to this is 1. Okay. Now, dict of 2. This is 2. Okay. One more row dictionary tiny dict variable. Here, name is a key and value is the Kishore. Similarly, code is a key and department is a key and sales is a value. Now we will access the elements of the variables. Print of dict ONE, it gives this is 1. Okay. Now accessing the dict of 2 variable. This is 2. See here. Okay. Now we will access the tiny dict. Here, tiny dict key and value pairs. Name, Kishore code, 274 department, sales. Okay. Now we will access the tiny dict variables keys using this tiny dict dot keys keys tiny dict keys name code and department. These are the keys name code and department. Okay, similarly we will access the tiny dict variables values dict here Kishore 2 sales. These are the values of the tiny dict variable. Note, dictionaries have no concept of order among the elements. It is incorrect to say that the elements are out of date. They are simply unordered. Dictionary is an unordered collection of key and value pairs. It is generally used when we have a huge amount of data. Dictionaries are optimized for retrieving data. We must know the key to retrieve the value. Let us see one example. D equal to curly bracket 1 is the key value here 1 is the key value is the value. Similarly key is the key and value is the 2. See the type of print type of D. It is the dictionary. Okay, now let us access the key of 1 key value of 1 print D of 1. It gives the value key 1 value is the value. Similarly you can access print D of key is the 2 here. Okay, now if we access print of D of 2, actually it gives an error. Actually there is no key with the name 2. Okay, let's see the difference between mutable and immutable. In general, data types in Python can be distinguished based on whether objects of the type are mutable or immutable. The content of objects of immutable types cannot be changed after they are created. Here is the list of the immutable types and mutable types. In immutable types, integer, float, complex, string, bytes, tuple, frozen set. All these are all the immutable types. Similarly, byte array, list, set, dict. These are the mutable types. Only mutable objects support methods that change the object in place, such as a reassignment of a sequence slice, which will work for lists but raise an error for tuples and strings. It is important to understand that variables in Python are really just references to objects in memory. Okay friends, in the next tutorial we are going to learn about the Python's type conversion and casting. If you like these tutorials, please subscribe this channel and please share with your friends. If you have any feedback, please type in the comment section. Thank you for watching, friends. Please see this tutorial lesson available in PDF file. Link is given in the description. Please download it for further reading. By Kishore Kumar Oja signing off.